Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 122, for broadcast on the 11th of October, 2023. Coming up on SpaceTime, humans and other mammals are likely to be extinct within 250 million years, strange, mysterious planet-like objects discovered in the Orion Nebula, and the link between Snowball Earth and complex life. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study looking at how continental drift will change the face of Earth into the future shows that the creation of the next supercontinent, Pangea Ultima, will probably have a side effect of causing humans and other mammals to become extinct. That's assuming people haven't already done so before then. The findings, reported in the journal Nature Geoscience, shows that Pangea Ultima forms around 250 million years from now, as a landmass comprising Australia, Europe, Asia and Africa merges with the Americas. This new supercontinent will trigger massive climate extremes, causing intense dry heat and making it difficult for almost any mammal to survive. The climate models suggest that the planet will undergo its greatest mass extinction event since the KT boundary Chicxulub asteroid slammed into the Gulf of Mexico's Yucatan Peninsula 66 million years ago, wiping out 75% of all life on Earth, including all the non-avian dinosaurs. This new research by the University of Bristol is based on new supercomputer simulations. It shows how, as the world's continents merge, they form a giant, hot, dry, and largely uninhabitable supercontinent studded with lots of frequently erupting volcanoes where the different tectonic plates meet and subduct under each other, and where former mid-ocean ridges are buried. The increased volcanic activity produces vast amounts of carbon dioxide, which is then spewed out into the atmosphere, further warming the planet. In fact, the authors think CO2 concentrations could rise from around 420 parts per million today to somewhere over 600 parts per million. The simulations also predict that the sun will become increasingly brighter, emitting 2.5% more energy, further heating the Earth's crust. Only around 8 to 16% of land will be habitable for mammals. See, the problem is while they've evolved to lower their body temperature survivability limits, mammals' upper temperature tolerances have remained pretty well constant. This makes exposure to prolonged excessive heat much harder to overcome, and the climate simulations, if realised, would ultimately prove unsurvivable. The study's lead author, Alexander Farnsworth, says the newly emerged supercontinent would effectively create a triple whammy, comprising the continental effect of moving tectonic plates, a hotter sun, and more carbon dioxide in the atmosphere. The result is a mostly hostile environment, devoid of food and water resources for mammals. Meanwhile, Curtin University-led supercomputer research has found that the next supercontinent will form in what is now the tropical Pacific Ocean. Apparently, that's because the thickness and strength of tectonic plates under the oceans tend to reduce with time. This makes it difficult for the next supercontinent to assemble by closing young oceans with thicker plates like the Atlantic and Indian. The study's lead author, Chuan Hung, says that over the past 2 billion years or so, Earth's continents have collided together to form a supercontinent roughly every 600 million years or so through a process known as the supercontinental cycle. Huang says the new supercontinent will form in the tropical Pacific Ocean as America collides with Asia. Australia is also expected to play a role in this event after first colliding with Asia and then connecting America to Asia once the Pacific Ocean closes. By simulating how the Earth's tectonic plates are expected to evolve, Huang and colleagues were able to show that in less than 300 million years' time, it's likely that the Pacific Ocean will be closed, debunking previous hypotheses. The Pacific Ocean's what's now left of the Panthralacis superocean. It started to form some 700 million years ago when the previous supercontinent Pangea started to break apart. It's the oldest ocean we have on Earth and began shrinking from its maximum size during the age of dinosaurs. It's currently shrinking in size by just a few centimetres per year and so should take 200 or 300 million years before closing up entirely. With most of the land all piled up in one place, creating new tall young mountain ranges, the sea levels are expected to be lower. The Curtin University results match those of Bristol University, finding that the vast interior of the supercontinent will be very arid with high daily temperatures. Huang says having the whole world dominated by a single continental mass will dramatically alter Earth's ecosystems and environment.
Scientists discovered over the last 30 years, all the world continents every now and then come together and then break up again, then come together again. And it turned out this happened at least 3 times in Earth's history. It's kind of like every 600 million years. So this research is, we try to figure out how does the supercontinent come together. And there are 2 or 3 ways of doing that. One is the supercontinent break up, then collapse inward, closing the new ocean. Yeah, the other way is they break up to keep moving away from the original place, then collect together on the other side of the globe, called extraversion, closing the ocean. So this research, we try to figure out why the supercontinent form in different ways and what's controlling it. Yeah, so after playing with a few different parameters, and we realized it's really the strength of the Earth's shell, we call it the shell, so literally under the superocean surrounding the supercontinent, that controls how a supercontinent forms.
It's not just the convection of material coming up from the mantle along the mid-ocean ridges that's causing spread. It's also the thickness of the lithosphere itself.
Yeah, it's both the convection, also the subduction. New ocean crust and lithosphere form at the mid-ocean ridge, but at the other end they go down. And really, how easy they can go down and go deep. That's what's controlling how a supercontinent forms.
You guys found that it's the thickness of the lithosphere that's changing as well.
This is a surprise finding actually. When we started this modeling, we didn't know exactly what's controlling it. Then we realized it's really how strong the oceanic lithosphere controlling how a supercontinent forms. And then we realized the ocean crust actually getting thinner with time because as the Earth cools, it produces less melt. The less melt causing the oceanic crust to thin with time. So kind of one-way traffic. The crust getting thinner and thinner. So turn out we only able to form a supercontinent by inward collapsing in some 500-600 million years ago, but not after that. So that led us to make a prediction for future supercontinent. They can only form by closing the superocean surrounding the supercontinent.
Yeah, it's interesting that we often talk about supercontinents and how they form and then break apart and new ones form.
That's right. That's nearly 30 years ago. The only real supercontinent is called Pangea. That formed before dinosaurs. Pangea formed like 320 million years ago and broke up about 170, 180 million years ago. Before Pangea, we know that was Gondwana. But Gondwana was only half of the continent. It's not really a full supercontinent. Yeah, you're right. Gondwana formed at about the Precambrian boundary 540 million years. And before then, we knew almost nothing 30 years ago. We only learned over the last 30 years that was 2 Pangea-like supercontinents formed even before Gondwana. Yeah, one called Rodinia, one called Luna. Yeah, Rodinia formed around 900 million years ago. Luna like 160 million years ago.
Now we're heading towards the next supercontinent, which you guys have dubbed, I think it's a name you guys have come up with, Pangea?
Amasia is a name coined by a well-known geologist called Paul Hoffman from Canada. He believed the next supercontinent will form by having the America continent colliding Asia, Australia, everything, including Pacific Ocean. So American Asia, called Amasia.
And there's no need for people to rush to Bondi Beach just yet. This will take 600 million years or something.
Yeah, nowadays we are in the middle of a supercontinent cycle. So the Pangea was 300 million years before now, and now Eurasia drifting to east, and America drifting west, and so we are right in the middle of the supercontinent cycle. Yeah, you're safe on living on the coast.
That's Chuan Huang from Curtin University, and this is SpaceTime. Still to come. Strange, mysterious planet-like objects discovered in the Orion Nebula and the link between Snowball Earth and complex life. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
New images from the James Webb Space Telescope have revealed strange planet-like structures in the Orion Nebula. The images, taken with Webb's near-infrared camera, show both planet-forming disks around young stars, as well as what appear to be free-floating planetary mass objects. The free-floating planetary mass objects seem to always be in pairs, have consequently been named Jupiter mass binary objects, or jumbos for short. These jumbos are gas giants, far too small to be stars. But the thing is, they're not orbiting around a parent star, as normal planets do. The discovery challenges existing hypotheses on star and planetary formation. See, the current doctrine indicates that stars are only formed by the gravitational collapse of cold molecular gas and dust clouds, while planets are only formed from the accretion of material in the protoplanetary disks surrounding a newly formed star. However, the discovery of so-called failed stars, known as brown dwarfs in the 1990s, began to blur this distinction. Now the detection of what appear to be Jovian-sized protoplanets, free-floating beyond any parent star, is providing further fuel for discussion among astronomers. The observations suggest that these objects are only about 1 million years old, relatively newborn in astronomical terms. They have surface temperatures of roughly 1,000 degrees Celsius, but that doesn't last very long, then they rapidly cool down before freezing. Even more baffling is the fact that these objects appear to only ever form as pairs, never individually. Now, the best hypotheses to try and explain them suggest that either they're formed in areas of the nebula too sparse to create proper stars, or they were formed as planets meant to orbit stars, but for one reason or another were ejected out of their orbits by some sort of gravitational perturbation with another object. The ejection hypothesis is favoured by many astronomers because it's known that planets can be ejected from their original star systems and left to roam the galaxy as rogue planets. The problem is that doesn't explain why they're ejected as binaries. There's simply no scientific model that can explain that event. Located some 1,344 light-years away, the Great Nebula in Orion, or Messier 42, is the nearest large star-forming ridge into Earth, containing quite literally hundreds of newly forming stars and protostars. The Orion Nebula is located inside the constellation Orion the Hunter. It's easily visible to the unaided eye as the middle star in Orion's sword. But a careful look shows that it's not a single-point light source like other stars. Instead, it looks a bit fuzzy. That fuzziness is because it's not a star, but an entire nebula, over 24 light-years wide, containing as much mass as 2,000 suns. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky, and it's amongst the most intensely studied celestial features. It's revealed much about the process of how stars and planetary systems are formed out of collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, the intense and turbulent motions of gases, and the photoionizing effect of massive nearby stars within the nebula. This is SpaceTime. Still to come, the link between Snowball Earth and complex life, and later in the science report, Earth's near-surface permafrost could be gone by the turn of the century. All that and more still to come on SpaceTime. A new study suggests that massive volcanic activity during the interglacial period between two of the planet's Snowball Earth phases may have helped with the evolution of early and complex life. The findings, reported in the journal Science Advances, are based on new research into the Pangea Formation in southern China. Teams from the Chinese Academy of Sciences took drill core samples of the region's interglacial stratigraphy spanning hundreds of metres for geological, stratigraphic and geochemical analysis. The systematic study included high-precision sulfur and mercury isotope analysis. This provided a new perspective, suggesting that the melting of the Snowball Earth induced large-scale volcanic activities. The authors investigated the changes in the Earth's surface environment and climate following the thawing of the Snowball Earth. The Tangpo Formation represents a significant source of large-scale sedimentary manganese deposits, providing a nearly complete record of the climate and environmental changes between two successive Snowball Earth events. The findings, based on multiple field surveys, provided evidence that the gradual oxidation of interglacial oceans created favourable environmental conditions which are crucial for the evolution of early and complex life. The study results indicate that during the initial stages of the Snowball Earth thawing, the chemical composition of seawater was primarily influenced by hydrothermal venting on the ocean floor. It shows fundamental differences between the ocean during Snowball Earth and normal ocean conditions. It seems Snowball Earth events severely limited the exchange and circulation of substances among the ocean, atmosphere and land. The variations in non-mass-dependent mercury isotopes provided evidence for the intensification of volcanic activity during Snowball Earth deglaciation. Now, the authors believe that what's happening is the rapid thawing of Snowball Earth led to a sudden reduction in the amount of pressure on the surface of the planet, thereby triggering magmatic activity deep within the Earth as that pressure was relieved in subsequent volcanic eruptions. They also identified anomalies in the sulfur isotope composition of pyrite in interglacial sediments. This included slight non-mass-dependent sulfur isotope fractionation. However, the sedimentary sequence clearly indicates that this minor non-mass-dependent sulfur isotope fractionation isn't related to volcanic activity. Instead, the fractionation was caused by Snowball Earth altering the sulfur isotope composition of seawater sulfates. Time variations of sulfur isotopes demonstrates a gradual increase in sulfate concentrations of interglacial seawater, and that indicates a progressive oxidation of the atmospheric and ocean systems during this period. The authors conclude that changes in atmospheric chemistry, a gradual decrease in surface temperatures, and the progressive oxygenation of the oceans during the interglacial period resulted in environmental and climatic changes in the Earth's surface that promoted the evolution of early complex life forms. The Snowball Earth hypothesis proposes that planet Earth has undergone several periods of almost, if not total, global glaciations. Now, Snowball Earth events are extreme glaciations, far more extensive than ice ages. These periods of icehouse climates resulted in the planet's surface being entirely or almost entirely frozen over with ice sheets, often up to 2 kilometers thick, and average surface temperatures of minus 50 degrees Celsius. Proponents of the hypothesis argue that Snowball Earth events best explain sedimentary deposits generally regarded as of glacial origins, but found in tropical paleolatitudes, as well as other enigmatic features in the geological record. It's thought the first Snowball Earth episode lasted from around 2,400 to 2,100 million years ago, and may have been triggered by the first appearance of oxygen in the atmosphere, known as the Great Oxygenation Event. See, cyanobacteria involved oxygenic photosynthesis and began reproducing at exponential rates, exploiting the abundant energy of the sunlight. However, over time, the oxygen they produced as a waste product saturated the planet, polluting Earth's mostly methane atmosphere, thereby poisoning the dominant anaerobic life forms for whom oxygen is toxic. Methane turned from being the dominant atmospheric constituent to simply a trace gas as it was oxidized into carbon dioxide and water. A different, thinner atmosphere emerged as a result, one with weaker greenhouse gases. Now, at this time, solar luminosity would have been much lower, and it was this combination which triggered the first Snowball Earth event. And there could have been other possible triggering mechanisms as well, things that changed ocean currents and weather patterns, such as the formation or breakup of supercontinents due to global plate tectonic movements. There could also have been changes in solar energy output from the Sun, changes in Earth's orbit around the Sun, and changes in the degree of Earth's axial tilt. Another Snowball Earth event some 750 million years ago may have been caused by the breakup of the ancient supercontinent Rodinia. That triggered extensive underwater volcanism, which released gases from the eruptions, which then saturated the oceans, removing carbon dioxide from the atmosphere. This allowed more heat to escape into space, which in turn increased global ice coverage. That caused a positive feedback loop, reflecting more sunlight away from the Earth and further cooling the planet through a tipping point to create a Snowball Earth event. The third and most recent Snowball Earth episode appears to have occurred between 650 and 635 million years ago, and that was just before the sudden rapid expansion of multicellular life forms known as the Cambrian explosion. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study looking back at some 3 million years of Earth's climate has concluded that most of Earth's near-surface permafrost could be gone by the turn of the century. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, shows that the amount of near-surface permafrost could drop by 93% compared to the pre-industrial period of 1850 to 1900. That's some of the most extreme climate warming scenario in the latest report of the Intergovernmental Panel on Climate Change. By the year 2100, Earth's near-surface permafrost, within the upper 3 to 4 metres of the soil layer, may exist only in the eastern Siberian uplands, the Canadian high Arctic archipelago, and northernmost Greenland, just as it did during the mid-Pliocene warm period. The study's authors warn that the loss of this much near-surface permafrost over the next 77 years will have widespread implications both for human livelihood and for infrastructure, as well as the global carbon cycle and for surface and subsurface hydrology. The paper's authors chose to compare Earth's projected future to the mid-Pliocene warm period, which occurred approximately 3 million years ago, because it's the most recent period of sustained global warmth in the planet's geological history. A new report by the World Health Organization has found that high blood pressure or hypertension now affects 1 in 3 adults around the world. The findings also show that approximately 4 out of every 5 people with hypertension are not adequately treated. In Australia, around 20 to 25% of hypertension is uncontrolled. But if treatment and control were improved, it could prevent up to 58,000 deaths by 2040. Archaeologists digging in Africa have found a 476,000-year-old wooden structure in the Colombo Falls region of Zambia, which may represent the earliest use of wood for construction ever uncovered. The discovery, which has been reported in the journal Nature, are centred on 2 preserved logs which were interlocked by an intentionally cut notch and an associated collection of wooden tools. The authors say it suggests that these logs could have been used to create a raised platform, walkway, or foundations for a home in an area subjected to periodic flooding. Another big week in tech, with Google Pixel 8 and Pixel 8 Pro now out. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, they've finally been officially released. Now, they'll go on sale on October the 12th. And there's a whole bunch of AI features, as you'd expect from Google. Things like the call screen where the phone can be answered for you with a very natural-sounding voice, somebody asking you, the person that's calling, why are you calling? And then it's going to pass the message on. It sounds like a real assistant. There's even a section with the camera where you can take a succession of photos, a series of photos. And, normally if someone is blinking or looking down or not looking directly at the camera, and then you can intelligently, the camera app, show you the other headshots. And you can choose the headshots where everyone is looking at the camera and smiling or, not pulling a funny face. It's something you have to see to truly understand. Other camera improvements are there. The computational photography means that with the 50 megapixel lens and with the telephoto, you can get this optical quality 10 times zoom, even though it's only got a 5 times zoom. And at least that's what Google is claiming. You've also got this audio magic eraser where if you're recording a baby making little noises, cute noises, and there's a dog barking in the background, you can isolate the baby and get rid of the dog noise, for example. Or if you're recording a street performer and there's all these car noises in the background, you can just isolate the sound of the street performer playing the musical instrument. The photograph editor, they're showing you somebody in a park and part of the image has somebody in a tent and the tent's half cut off. You can actually drag that tent to the right-hand side. It'll fill the rest of the tent in that's not there, and then you can make it bigger. So you can actually edit images and create whole new images. There was another image where you could see part of the Golden Gate Bridge, but part of it was obscured by fog, but you could zoom in and it would fill in the rest of the bridge. I mean, really magical stuff, helping you to use generative AI in ways that is a lot more interesting than just asking ChatGPT a few questions. So there's tons of really cool features inside there that show that Google is really trying to one-up not just Apple, it's in the perpetual fight against Apple, but every other Android smartphone maker, Motorola, Oppo, Xiaomi, Samsung. I mean, one of the other features is 7 years of not just security updates, but OS updates. So if you buy a Pixel 8 or 8 Pro this year, it'll keep working until 2030. I mean, it'll obviously work for longer than that in theory, but you won't get security updates anymore. And I was getting the September update on one of my Pixel phones, last month, and I had this Motorola phone, and even though it had Android 13, its most recent update was in April, and it's like, well, aren't there a whole bunch of updates for security that just aren't there? So Google really wants you to think about who are you going to buy your phone from, and they're obviously hoping very much that you'll buy theirs as opposed to Samsung's or anybody else's. So we've also got the Pixel Watch 2 with a bunch of improvements and a new Fitbit Charge 6, and also the Google Pixel Buds Pro, which will make the sound of your voice clearer by using a high bandwidth Bluetooth connection, and also cut down some of the noises that are around the person you're listening to.
And I can't let you go without asking you about the latest controversy regarding the iPhone 15. It's becoming a hot item, quite literally.
Yes, but the funny thing is, whenever I read an article about that, there's talk that the iPhone 14 with the iOS 17 update is recording similar temperatures. So I suspect it's not actually the iPhone 15 as such, but it's iOS 17. And in fact, as we're recording, Apple has today launched iOS 17.0.3. So when you're listening to this, it'll definitely be available for your iPhone. I would absolutely recommend that you download it straight away for all of your devices, not just the iPhone 15. But another bug that's been happening is with the iPhone 15 charging wirelessly in certain cars that have a wireless charging pad. And apparently, for some reason, that's burning out the NFC chip. And people have taken their phones back to be replaced. They get another one, and the same thing happens. So whether that's fixed in the latest update, I don't know. But I wouldn't be wirelessly charging my iPhone in a car until you get the all clear that this is safe. Otherwise, you might find your NFC chip is fried.
And what else is on the website this week, Alex?
Well, besides being able to watch the Pixel videos, there's Samsung's new Fan Edition phones, Spotify giving audiobooks to its premium subscribers, the 20th annual Cybersecurity Awareness Month, McAfee's new AI internet-powered security, many Quest 3 headsets and Ray-Ban glasses, and more. Please check out techadvice.life.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.